Hello everyone, welcome to your lab video for lab activity 12. So this is going to be, I guess, like one of the few remaining lab activities that we do very closely, written to what's published in the Chem Activities and Lab Activities book by Dr. Nichols. So let's see. Step one of the procedure is to prepare an aluminum soda can according to what they say, and so on and so forth. I've already got 2 holes punched in this aluminum can, so it's really not necessary for me to cut off the top unless I really want to, which I don't. So I'm not going to. And I'm supposed to weigh this can and record the mass. I'll do that in just a second. Real quick, I'm going to skip ahead to step 2. I'm supposed to take some ice in a beaker, and I need to fill this beaker with tap water so that we have some water that is cooling down to about ice temperature. So in the spirit of getting as many things done as possible in as little time as possible, I'm gonna fill up this beaker with the tap water first so that the tap water can reach the ice water temperature while I write down the mass of this empty can. Okay. So that was 13.114 grams. I don't know why I just wrote that. All right. And let's see. I have also obtained a ring stand. Here we go. So here's the ring stand. Here's the iron ring. I've already set it up there. Let's see, that is covered. I'm gonna wait just a little bit longer for all of this to reach a cold temperature, as cold as possible. Okay, that's cold enough. All right, so now I'm going to place, let's see, I've already got that. I've already let it chill. So now I'm going to pour the chilled water into the can. I do not want to transfer any ice. Okay, so what we're trying to do is we're trying to track how much heat is needed to simply raise the temperature of the water that we have in here. But as we've been learning, there will also be a certain amount of heat required if there's any ice to melt, right? So we want to make sure that any and all water that we pour into this can is all going to be liquid water, just cold liquid water. Oh, I couldn't see what I was doing. So now this is pouring out the sides. You know, we all make mistakes. I need to weigh the can after adding the water, and of course I need to record the mass, so be right back. That's 276.10 grams now. All right, so again, that's the mass of both the can and the water. All right, so we've got a mass of the can when it's empty. We've got a mass of the can plus the water. So by subtraction, you can determine how much of that mass is due to just the water, okay? All right, so we take the stir rod, we stick it through the holes like so, and then this way the stir rod is gonna help the can be suspended like so. Woohoo. All right, so I also have to get my alcohol lamp, which is decently full, and I'm going to record the mass of this before I do anything. 182.23 grams. All right. And the last thing that I need to do is I need to take an initial temperature reading of the water. I also want to make sure that there's as little space between the wick and the bottom of the can as possible, and yet enough space for there to actually be like a flame that burns, you know. Find that happy medium. Okay. And my thermometer has stopped decreasing temperature, and it's reading at 2.5 degrees Celsius, actually 2.4 degrees Celsius. Right on, right on, right on. Okay, and so here we go. We want to light this match as quickly as possible so that if the water starts heating up, so that if the water starts heating up, then we can be assured that it's due to just the burning of the ethanol and not due to the water absorbing heat from the warmer air in the room. Okay? All right, so this is gonna take a little while, so I will see you all in about 5 minutes. All right, here we are, welcome back. So I have now reached the point where I'm supposed to stop. According to step 4, when the temperature of my water is greater than 50 Celsius but under 60 Celsius, I need to blow out the flame and stop. All right, and so now we are at 54.6 degrees Celsius. So it's definitely time to extinguish the lamp by blowing on it. Okay, so here we go. But then I need to continue measuring the temperature of the water. So right now it's 55.8 degrees Celsius. I'm supposed to record the highest temperature reached. Sorry, I know I'm not being super good about this. There we go. Now you can see me. Oh, and then we just dropped to 55.7. All right. I think we're gonna keep falling from here. So my highest temperature reached was 55.8 degrees Celsius. So that's what I write down for the maximum temperature. So then step 5, again, weigh the alcohol lamp and record the final mass. So here we go. 178.05 grams. All right, so again, by subtracting those two ethanol masses from each other, or at least ethanol lamp masses from each other, we can figure out how much ethanol must have burned in this process. Okay. All right, so the general idea is that we then relate the heat absorbed by the water by plugging in all of those numbers, as you can see on your report sheet. And then, well, ideally, you know, where did the water get that heat? This is a Blue's Clues moment. Where did the water get the heat from? Well, it must have gotten it from the burning of the lamp, okay? So if the water absorbed a certain number of calories of heat, it must have gotten them because the burning of the lamp gave off exactly that much heat. So, however much heat is absorbed by the water is how much heat got released by the alcohol. So practically, those two numbers are exactly the same. So don't overthink this. The heat absorbed by the water equals the heat released by the alcohol. Okay? So then the final step is to calculate the heat released by the ethanol per gram of ethanol that you burned. Okay? So you'll take that heat released by the ethanol, which is just in calories, right? And you gotta also use the mass of ethanol burned, and you're looking for a number that has units of calories per gram. Okay, so we've calculated quite a few numbers in this way before. We've found concentrations in moles per liter by taking our moles and just dividing them by the liters, right? And then whatever number you get is moles per liter. You're gonna do the same thing here. However many calories must have been released by burning the ethanol. You just take that, you divide it by how many grams of ethanol you burn, and so then that number is the calories burned per gram, okay? So, yep, you can do this. All right, so then after this, trial 2 happens exactly the same way. All right, so I'm not going to film myself doing this, but I'm going to empty this can. I'm going to let it cool down. I'm going to reweigh the ethanol lamp for an initial measurement, just in case, because I'm a little paranoid like that. You never know if it's going to change masses. Same with the can, I'll reweigh the empty can. And then I've already been letting more ice and water sit here. So I'll have another batch of cold water to then pour into the can, and so on and so forth. Okay, but the process is going to be exactly the same in trial 2 as it was in trial 1. Okay, so what you're going to get from me is just a trial 1 set of data and a trial 2 set of data, both of which you should be transferring to your report sheet, and then you need to calculate these numbers, and then you need to carry on to the follow-up questions and answer them to the best of your ability, but you can do it. Okay. Hopefully in question 1, follow-up question 1, you can trust that, well, this is the data that your teacher obtained, and you all know the high standards that I have for conducting lab experiments, so hopefully you can trust that I didn't make any mistakes. Side note, I know that I did make the mistake of pouring in so much water that it started pouring out the side holes. However, I made sure to dump out the excess water, and I dried off the outside edges of the can, and I made sure that no additional water could drip out. So even though we had that little mess up right there at the beginning, I fixed it well enough that that shouldn't and would not even contribute to any further error in the data that I obtain. All right, so human error shouldn't be anything that you're bringing up, or Professor McBain made a mistake shouldn't be anything that you're bringing up. Okay, so you've got to think a little bit more outside the box here about why your values, your average value of the heat of combustion of ethanol might be different from those 7,091 calories per gram that they say I should have gotten. Okay, but we can pretty much trust that they're going to be different. I think that's it from me. So, take care. See you later.